Okay, so welcome back to the practical. In this practical, you will mostly be using the BEAST program I was describing, and you'll be using it on the bird flu data I was describing. In fact, this is it's highly pathogenic H5N1. It's the HA, the hemagglutinin segment. There are 92 sequences from approximately a 10-year time frame, and it's from domestic galliforms, chickens, that's chickens and turkeys, domestic antheriforms, wild antheriforms, and it's from several regions in Asia, Africa and Europe. Roughly, there's 5 tasks to do, and each task there's quite a lot of steps for each task. Roughly, first of all, you will check the clock-like behaviour of the sequences using a program called Pathogen. Then, when you're satisfied that there's a nice strong clock signal, which of course there is, but you know, good to check, you will set up your BEAST. You'll set up a BEAST analysis. Now, BEAST, as I was describing, there are many models and parameters to set and lots of things to do. When you set up that analysis, what you use is you use a subsidiary program called Beauty. What Beauty does is it allows you to set all the parameters and models you want to set, and it writes out an XML file. That XML file, it's a configuration file, which then tells BEAST exactly what to run. What I've done is, what I'd like you to do is set up those XML files and start to run one instance of BEAST. But just start it going and then you can stop it. Now, the reason for this is BEAST is a complex model. It's called BEAST for a reason. And it takes a long time to run. So what I've done is I've actually ran a whole load of models for you. And I'll show you where they are. They should be on these computers in a minute. And some of which take, in fact, you know, from my point of view, this is a small data set. 92 sequences is actually quite small. Some of these models were already taking 6 hours to run. Just to let you know that in my work, I will generally deal with several hundred up to 1,000, and I'm often running things for 3 weeks on a server. So anyway, I've made some for you to have a look at the output of. So in the third task, I want you to look at the outputs that I've already run using a program called Tracer. So this is a thing where you can see the, all those posterior distributions and things. And those use the log files. Then, when you're happy that your chains have converged and you've got nice samples, I want you to make trees, MCC trees from the trees file and display them in Figtree, and then you can, I think you use Figtree this morning, but there are many extra settings in Figtree to add the timescales, to add the colours according to location or host. And then finally, I want you to plot the spatial trees using the program called Spread. So this is where you're mapping the trees onto the globe. This gives you, so in the lecture I showed you sort of static images, but what this actually does is it gives you things called KML files which open in Google Earth, and that allows you to use a slider to see how these things change over time, and what you'll see is kind of lines moving around the globe as you change the slider in Google Earth. Again, as Emily said this morning, I want you to keep an electronic logbook of what you have done, including the settings, the lovely figures you will be generating, answers to the questions. There will be some questions in a minute. And your own observations. This is really for your own benefits, because when you come back to it in a few months' time, you'll think, what did I do? So I think it would be good to have a record of this.